Hello, my name is Andrew Lamb. I'm a staff engineer at InfluxData and an Apache Data Fusion PMC chair. Today I'm going to give a talk about Introduction to Data Fusion. Specifically, I'll talk about technology, the community, and how we always need more help. Not quite enough time. This is a version of a talk I've given at many of the meetups I've been to in the last year or so. However, I know that only a certain subset of people can go to those, because they're in some physical location. And due to basically my own technological failings, I have yet to be able to successfully record one of the times I've actually given this in person. So instead, I'm just going to record it in my hotel room here, and hopefully other people who might be interested in this topic can see it too. So I'll start first with what data fusion is technology-wise at a high level, right? So it's a top level Apache Software Foundation project. It's Apache 2 license. It's one of the most permissive open source licenses out there. Here's the website. And what it is I'm going to describe starting with an analogy, right? So this is a super nerdy analogy, but I think it's the best one. Maybe it's because I really love data compilers in the grad school. But basically, data fusion is the LLVM for database. Now, to explain even what this is, you have to understand what LLVM is. So LLVM stands for, I believe, low-level virtual machine, and it's a suite of tools. It's a library that underlies a lot of the modern programming languages you know. And the reason it's valuable is because when you're looking to create a new programming language, there's all the details about the actual language you have to worry about and the ecosystem and all that sort of stuff. Uh, but then there's an awful lot of things you need to be able to provide to your users to give them like what they would expect out of a programming language. Like there's a whole bunch of optimizations they expect you to do so your code is fast, and you need to have debugger integration, and you need to integrate it into a language server maybe, and you need to be able to generate code for both uh, you know uh, Intel and AAR64, and there's a bunch of other stuff that is not really specific to your language, but it's required to have a good experience. And so prior to the advent of LLVM, if you wanted to make a new programming language, you had to build everything from the ground up, including all the sort of standard but required things that really weren't specific to your language. It's part of the reason why we saw languages like like GCC was the compiler for a very long time. And recently, we've seen an explosion in new systems programming languages. I attribute that directly to the advent of LLVM, because now you can instead, when you're writing Rust, you don't have to invest the same enormous amount of effort building that low-level infrastructure. You can instead focus on what makes the language better. And I think we've seen lots of innovation due to that commoditization of the reusable piece. So data fusion is basically the same thing, but for databases, or at least analytic databases. That's my way I think about it. So at this point, we've re-implemented probably for the last 15 years variations of streaming vectorized execution engines that have SQL planners and various optimizations, very similar to the LLVM, where they're like constant folding, constant propagation, join rewriting, all that stuff is very standard, but still people continue to reinvent it over and over and over again in tightly integrated systems, and it makes implementing a database from scratch like a very expensive proposition. But a lot of those optimizations are very general purpose and basically apply across everything. So the idea of data fusion is you can start, it has all the core pieces of an analytic engine that you need, like SQL and an optimizer and a big function library and a bunch of optimized execution operations. And instead, then people who build on top of data fusion can focus on like the language design, how you're going to manage your data, whatever use case specific features you want. And so I think the promise of this is that you're able to we'll see lots more people have very high quality analytic systems, right, that are very fast and high performant because they can build on top of this shared engine that will all work together to improve. And then you can spend most of your time and energy focusing on stuff that makes your system specific be better. So that's the pitch. It was kind of like a dream a couple years ago. It's now being a reality. I've seen it in a lot of different systems. We'll talk about this. So at a high level, this is the high level architecture of data fusion. If you've ever seen the internals of how databases are implemented before, this should not be surprising. This is basically exactly how pretty much all databases are organized, or they might use slightly different terms, but they all basically have the same structure. So data fusion comes with catalogs and data sources. So in this case, it has reads Parquet, reads CSV, a bunch of other JSON, a bunch of other file formats. You also have you can write queries in both SQL, and then there's also a data frame front end. There's then a relational logical plan, which is like a high-level relational operator tree, which describes the calculations that are required to compute the queries that are requested. It also includes a variety of optimization passes to make those logical plans faster. There's then a lower level representation of the relational algebra tree called an execution plan. That's often called a physical plan in other systems. But again, there's a whole new variety of set of transformations that happens there. And then it includes a variety of specialized operators that do the standard relational operations, right? If you don't know what this means, that's fine. But if you look inside, you'll need to like evaluate expressions efficiently, group, aggregate data, hash aggregates, joins, sorts, and all that sort of stuff. And what makes Data Fusion unique is that, I've written in blue here, you have all the basic stuff in green, but you can basically extend everything, right? So you can add your own data source. You see that in some other systems. You can put your own front end. I think that's less ideal, right? You can basically make your own domain specific language. You can also add your own logical plan nodes, your own rewrite rules, both the same thing with the physical plans. And then you can also add your own customized streams. So basically it's designed to be able to extend everywhere. So it's not a system, it's a library. And so with that, the high level goals of the architecture really is that you can start with very, very little effort, right? It's like 3 or 4 lines of code. It really is that because it's just a library and you can have like a fully functioning SQL engine, but then you can customize all of its behaviors via APIs. So that's like basically the goal. And one of the architectural principles, therefore, is that it basically tries to follow industrial best practice. I like to say that's architecturally boring, right? We're not typically implementing whatever came out of CIGMOD or VLDB this past year. Right? Instead, we've implemented something that other systems have done before. It works well. And the whole point of Data Fusion is not to invent something new and try something crazy. It's to share the load across people. So I think that makes it pretty good. It actually ends up meaning that it's very easy to specialize this engine. So some people use Data Fusion almost entirely unmodified, and some people modify it super heavily, via these APIs. And that makes it easy to try out different ideas, right? You want to have a different operator, you want to try a different query language. It's much lower cost to do that than starting with Data Fusion than if you had to write the whole thing from scratch. Now, we also had top of the line performance, right? It's one thing if you have this extensible engine, but if it's not very performant, Data Fusion is very performant. It's basically at the same level as other top engines like ClickHouse and DuckDB. In November, we actually were briefly at the top of the ClickBench benchmarks. I don't think the DuckDB guys like that very much, so they put a lot more effort into their Parquet implementation and have subsequently bumped up. But basically, we're in the same. The point is, we're basically in the same performance, right? We're very close. This gap looks terrible. It's not actually a 2x gap, right? Like the way ClickBench weights queries is a little bit weird. I know exactly how to fix this. If you want to come help, we'd love some help to fix it. It's just a matter of engineering time. Right? I don't have, unfortunately, the luxury of 19 people from CWI making it greater again. But we have all the internet. I expect we'll get back up there. We just need your help. So come on, help us. Anyway, but the performance is very, very good. My personal goal was to have 1,000 projects running on Data Fusion. And a couple of years ago, that was basically some crazy number I made up that wasn't like totally outrageous, but it was pretty ambitious. Now, I wouldn't be surprised if we've already hit this number. I don't, you never know. It's an open source project. But at this point, I have lots and lots of actual people who have used it, and of course, then there'd be a huge long tail of things I have no idea, and I find out every day, seemingly new projects that are using Data Fusion that I've never heard of. So I feel like it's making good progress. Here's an example. This was a fun slide to put together of a variety of startups. I know that new startups that are working with building products with Data Fusion. Also, there's a whole bunch of mature ones that have been around for several years. There's several, I know of several big established companies that are effectively using Data Fusion to optimize internal systems and processes. Sometimes you get details about what that is. Sometimes I have no idea, right? But you see people contributing back and trying to help. And then actually it's also kind of cool. I know of at least 2 startups that had Data Fusion based products that were acquired recently by larger companies. So SDF Labs was acquired by DBT, Arroyo was acquired by Cloudflare. And then both of those companies have sort of subsequently announced or have been working on Data Fusion powered either products or internal things. So like the Fusion engine in DBT Labs, you might imagine is probably going to be based on Data Fusion. Not just the name, you can read about it. That's what they're going to do. So anyway, I'm quite pleased with this list. The actual number of users is probably quite a bit higher than this, but these are the ones that I know of. I could tell you what each one does. Likewise, it's not just another random open source project. We actually know what we're doing. At least, people in Sigmod seem to think so too. They accepted a paper we wrote last year that basically just talks about data fusion, describes its architecture, shows that its performance is on par with other things, other similar systems like DataDB. And like the point of this is that it's serious technology. We have people who really know how to build database engines involved in the project, and it really is sort of what you'd find in the best of class proprietary system. CMU also has a great seminar series every fall. Last fall, they had one of them, database building block series. It actually turned out it was pretty much a who's who of data fusion users, which I didn't fully appreciate at first. Uh, there were two talks that weren't data fusion related. That was ParadeDB and OpenDAL. ParadeDB, in fact, was at one point a data fusion user, and Philippe tells me he might be back at some point soon. But it basically, so a lot of these people building on top of the database, this composable database architecture, have been using data fusion, which is kind of cool to see. So what are the main use cases for data fusion? Big set of use cases is specialized database systems. This is probably the biggest class of users, or at least the ones I know the most of. So these are people building, like often there's special observability or AI systems or vector databases or bioinformatics, streaming systems, that kind of stuff, that they'll use data fusion and customize it to run their system. We've also seen people use, so that those are whole database systems. We've also seen people use data fusion just for the execution engine. So in this case, there's a project called Data Fusion Comet, and there was another one called Blaze, I believe, that I know of. There's probably other ones that these take an existing front end, in this case Spark, right? People write queries using Spark SQL and that API, and then the actual execution engine falls down as native code, and the native code that Comet uses is the Data Fusion execution operators. Right, so this is like, instead of using Velox, this system uses the Data Fusion execution engine. We've also actually interestingly seen data fusion used in file format implementations, which is not immediately obvious why you need like a query engine in a file format. But it turns out with file formats, you get two things. You typically will compute some amount of statistics when you're writing the file. So that looks, depending what the statistics are, you might need a pretty sophisticated aggregator or whatever. And then actually, when you go to decode, a lot of these file formats rely on predicate pushdown. So, and effectively evaluating expressions to prune parts of the file using zone maps. If you don't know what that is, that's fine. But the point is, building a high performance file system basically requires pieces like parts of a query engine. And so we've seen people use data fusion to do that. We've also seen people use data fusion to do table formats. So, for example, I believe we currently have the trifecta of the Rust implementations of these table formats: Delta, RS, Iceberg, and Hootie. The Rust implementations all use data fusion, and that's because these table formats have both a read component to them, but oftentimes they'll have operations that look sort of a lot more like what a database system would do, like having to compact files, for example, is basically merging them, which is typically a database execution engine. Doing change data capture, deletes, and delete predicate evaluation, all that stuff is you need basically a query engine, and these people have decided to use these projects have decided to use data fusion to do that rather than re-implement it themselves, which was a good choice in my opinion, although I am somewhat biased. Another interesting use case that I never even thought of when we first started data fusion that is kind of cool is people using data fusion for SQL analysis. So that this is what SDF's products did. They took different SQL corpuses from different languages, right, different dialects of SQL. They compiled into a common intermediate representation. In this case, they use a data fusion logical plan, and then they were able to do static analysis, right, with like different SQL flows. You could actually do lineage analysis and dependency tracking and all sorts of stuff. And actually, it turns out then once you have a logical plan that you could run, there's a whole bunch of other interesting things they could do as well. So again, like this, if you're familiar with the Fusion engine, they've been talking, DBT's been talking about recently. It's a variation on this type of topic. So yeah, so that's basically the high level overview of what people do with data fusion. It's kind of cool. And now I want to talk a little bit about the community part. Not quite enough time, which is me basically begging you to come help and join the community. So Apache Data Fusion is an Apache Software Foundation project. So the Apache Software Foundation is a nonprofit organization that governs the open, it basically provides some high level structure to help govern open source communities and defines how they run themselves. It's been very successful. There's lots of well-known projects that are part of this foundation. For Data Fusion, in my opinion, the benefits for being part of Apache are at the core, it's a very, very predictable foundation and it lets people work together. Like that's the core benefit you get out of it. It's predictable in the sense that the license for Apache Software Foundation hasn't changed in 20 years, right? The Apache license 2.0 is basically the gold standard for open source licenses. It's very permissive. You can do whatever you want. It doesn't change. As part of Data Fusion is part of Apache. It won't be changing either. So, it's very reasonable to build a business or software product on top of this because you don't have a license risk. One of the major things that Apache requires, actually almost one of the only things that it requires, is that pretty much all communication is in the open. So it does result in lots of stuff, right? There's lots of tickets, lots of emails, lots of everything. But the information's out there. So if you care, you can go find it. There's nothing happening behind closed doors or sort of proprietary, or you're worried about backroom politics or anything. Like it's all in the open. And I think that's very successful in attracting multiple vendors to participate. So it's not just, there's actually quite a few people building, depending on how you look at it, somewhat competitive products to InfluxDB, and yet we're all able to use this organizational structure to work together, basically to share investment and reduce individual risk. Right? So everyone can kind of chip in a little bit, everyone gets the benefits, and you end up being sort of hedged against various bad things that can happen to open source projects, right? If you're familiar with some of them, sometimes the maintainer, has has a life change, they have a kid, they get married, whatever happens, they are no longer able to devote the same time to the project. And if you have no community around it, like that's it's a very dangerous place for the project to be. Likewise, companies' priorities shift over time, and that's sort of natural. So by being part of the Apache Software Foundation, there's a that priority is not going to change. It's basically much more steady and less subject to cycle shifts than typical corporate strategies. And then, of course, VC funding cycles, right? If you're working on a project that's funded by a VC-backed startup, at some point, they might have to pivot or they might have to adjust their business model depending on how things are working. Again, like that's fine. That's natural. That happens. But having sort of the Apache Software Foundation as the umbrella organization reduces the risk for people. So I probably already talked more about this than I should. In my opinion, this works far better than I ever would have reasonably expected, coming from like 15 years, 20 years of commercial software development experience, but it's amazing how well it works. Some numbers for what Data Fusion is it wasn't actually started or donated by a company, unlike a lot of other sort of open source projects. It was basically a side project from a guy named Andy Grove, who's great, still works actually on Data Fusion. He works on Data Fusion Comet, and he donated it to the Apache Software Foundation in 2019. The current numbers, according to GitHub, are 808 distinct contributors. Those numbers are slightly inflated due to how GitHub history is set up, and this used to be part of the mono repo. I think the real number is probably closer to 700, but that's still a very significant number of individual contributors. We have currently 17 people on the PMC, which is the overall governance committee, and then there's 47 people with write access to the files, and that's probably, I don't exactly know how many distinct companies, but that's over approximately 30 maybe distinct companies. It's not heavily dominated by one company. And then the most recent release we released was 47. I did the numbers. There's 93 distinct contributors who contributed code to that release. Those releases happen monthly, right? So we've had monthly releases for the last 3 years, and we're still at it. We still end up with multiple commits a day from multiple different people, which is somewhat overwhelming sometimes, but it's, I think, still cool to see the velocities going. One other interesting thing about this model is I don't know of anyone who's fully paid to work full time on Data Fusion. There's definitely people who are paid to work on Data Fusion, but often what they're doing is they're paid, they're working on a project built on top of Data Fusion, and then they either need a feature or a bug fix, and they'll go contribute that back upstream. Right. So it's not that Data Fusion doesn't have people paid to work on it, it's that there's no one directly funding the project only, right? So like I said, no one, including myself, is paid to work full time on Data Fusion. Instead, we're all kind of working part-time. I'm lucky I get to work, about half my time on Data Fusion and related technologies only. But And again, I would love to have a bunch of people who are working just full time making data fusion better, but instead we're got this notion where we basically got to all work together to make it better, and no one's going to come do it for us. So it's amazing what we can do with it. I do sometimes wish I had a research lab full of people who graduated, from top database research institution working for me, but hey, that's just the way things are. And so what the practical implication of this means is that the roadmap is determined by those who contribute, right? Like, so there's not some roadmap that that is being driven by outside quarters. Like the people who are going to do the work are the ones who get to decide where the project goes, which I do think in a high level is a nice alignment of interest. So with that, I'll throw in my AI generated slides about people hacking on databases. So please come work. Once upon a time, there were very few places physically in the world where you could work and get access, get a chance to work on database internals. The fact that now this is an open source global community is actually pretty neat. Lots of, I think there's many more opportunities for people who are into this kind of stuff to work with us. And it's not just, you want to get deep in the guts and optimize something. We love that. We love the code, love bug fixes, but we're always also looking for people to help review code, help like try the documentation if it doesn't work, help improve that, help triage tickets, right? Help other people figure out what's going on with their stuff. So I invite you, if you're at all interested in this, please come find us and help us help move it along. I think you'll find we're a pretty good group of people. So yeah, I have to basically end all these talks with please come help us, right? I love fishing for help. It's all I got. So if you're interested in working on databases, please come check us out. This is now when we normally in most of the meetups would go on to talk about the different other topics that we're going to discuss. But thank you very much for bearing with me with this particular example presentation, just to show you what the overview was. Here's the website. You can go to the Data Fusion main website. Almost all the activity happens on GitHub, which you can see the link there. And if you want to find us in Slack or Discord or whatever, there's a page on the website that's linked. So anyway, thank you very much. I hope this was interesting, and I'll see you hopefully at the project, right, where you're going to come help us. All right, thank you.